So we are going to continue the NIST SP 800-204 series of publications with 204C. And my dear colleague, Dr. Ramaswamy Chandramouli, or simply Mouli, as he modestly introduces himself, will discuss the implementation of DevSecOps for a microservices-based application with service mesh. Mouli, please take it.
Thank you, Michaela, for the nice introduction, and thanks, David, and the conference organizers for providing me an opportunity to speak. And today I'm going to give you a conceptual guidance on the DevSecOps. So it will contain all the building blocks and then how it is actually implemented, and also some of the benefits, but purely in the context of a modern distributed application, which consists of microservices and service mesh, about which we have heard a lot in detail now from Zach. Next slide, please. So yeah, this is the title of the talk, the implementation of DevSecOps for microservices-based application. So we have taken a reference application and a reference platform for describing this, but we are not getting down to the individual product offerings and so on, but we have to make our ideas concrete and to explain the concepts. Now we have taken this reference platform and the reference application. Next one, please. So those are the various topics we are going to be covering today. So initially, to begin with, give an introduction for the reference platform and the application, a brief introduction, no doubt, and then the various code types that are involved, because this is really important, because the DevSecOps pipelines applies to all types of codes, and then what are all the basic building blocks of DevSecOps, and then how you can put together all the component pieces and implement DevSecOps. And then lastly, the benefits of DevSecOps. So next slide, please. So the reference application we have taken is a modern distributed application. That's the terminology that Zach used. It consists of a microservices-based application with a service mesh, where all the application services are provided with a service mesh. And in this environment, we can identify about 5 different types of code types. But I must, of course, say now that there is definitely some overlap depending upon the platform for these code types. They are not completely mutually exclusive. But for the purpose of discussion and giving a conceptual view, to have these code types is really useful. So they are the application services, and then infrastructure as a code, and policy as a code, and observability as a code. And then all those are implemented on a reference platform, which is usually one that an orchestration and a resource management platform, like any of the Kubernetes flavors. And because invariably microservices are implemented as containers. Next slide, please. So here is a very brief overview. I think probably this is, I didn't have to even have this slide because I'm preaching to the choir, but anyway, to have the introduction complete. So the microservices is a couple of loosely coupled components, and they communicate with each other across the network. And then the beauty about this, since it is loosely coupled, it can be independently developed and scaled and so on. So it need not have to be on the same operating system or even the language and so on. Service mesh, as we have been hearing this morning, is a centralized infrastructure or a dedicated infrastructure. Instead of providing all the services in silos, it provides a centralized means of providing all the services, starting from service discovery, establishing secure sessions, authentication, authorization, and all the network resilience functions, like establishing the routes, and then the retries, the canary deployments, and everything that goes under the umbrella of network resilience. And then last but not the least is to monitor the applications so that have been already hosted. So all this is going to be done by the service mesh, independent of the application code. And that's the advantage of this dedicated infrastructure. Next slide, please. So now we'll have an overview of the various code types in our reference platform. As I said, the identification of these code types is very important from the point of view of describing the various fundamental workflow in DevSecOps called the pipelines. So that's why we are going to have a brief overview of these code types. So what are these code types in our reference platform? Next slide, please. So the first is the application code. Of course, this is the one that contains all the business transactions and the application logic. And then it will also have a connection to the backend database, and then accessing the database, writing to the database, and deleting from the database, all the database access functions the code will have. Next, we come to the application services code, and this is the code that actually going to reside in the service mesh. And this code actually exists in the control plane of the service mesh, and the various policies like authentication, authorization, and even session establishment are all pushed down into the enforcement point called the envoys that Zach talked about in the previous presentation, which is the policy enforcement entity in the service mesh. So, and then the next we come to the infrastructure as a code. This infrastructure as a code came about because initially when we want to host something on the cloud services, the cloud providers started providing what is known as the API. So this is a one step, even a level of abstraction beyond the API, in the sense that you describe all the computing, network, and storage resources that you need to deploy the application in the form of a code. And then when that code is executed, the deployment action happens to deploy to the various these types of resources, computing, networking, and storage resources, your application package or the application components. Next slide, please. So we have seen so far 3 types of code types, and then the 4th type of is policy as a code. So in other words, you got in the morning presentation, there was also to talk about the open policy agent and so on. All these policy tools help you to express policies in terms of a declarative code, and then those can be used to generate rules and configuration parameters, and all in the enforcement platform in the envoys and so on. So some examples of policies are zero trust policies, which are heavily based upon the identity and the associated context variables. And then you do have compliance requirements like healthcare data, the HIPAA requirements. And then of course you do need some policy parameters too for giving the users the best experience in terms of response time. And then the last but not the least is the observability as a code. So this also Zach talked about as part of the service mesh. So in other words, there can be an overlap with the service mesh, or it can be written independently, because after all, the functions associated with observability are done by specialized tools like the log tools that log the individual transactions, and also the log aggregation tools that can aggregate the logs. And then you do have tools that look at generate the various metrics like the node utilization and even down to the service utilization. So those are some of the metrics that could be generated. And then of course, when you have a distributed application, a single application request may involve calling several individual components or microservices. So for each call, application request, what are all the sequence of calls that are made? So you need to know whether the right sequences are made. So that's why you do have the tracing tools and combining all this to produce, generate a global view using the monitor or the dashboard. Next one, please. So we will get into DevSecOps basics. Next one, please. So what is a DevSecOps? It is an abbreviation for Development, Security, and Operations. And then many of you know what are the drivers for DevSecOps: security, scalability, best practices, and agility. Next one, please. And then the fundamental concept in DevSecOps is a concept of smart workflows called the pipelines. The pipelines, nothing but call, and the pipelines are defined for each and every software development lifecycle stage, like build, deployment, operation phases, and electively they help you to take the software from the initial code changes to the build stage, to the deployment, to delivery and deployment stage. And that's what the pipelines do. Next one, please. So this is a brief, and then there are two fundamental pipelines, all the continuous integration, the pipeline, and continuous delivery / pipelines. The CVD is an overused term for both delivery and deployment. So the delivery may deploy the software to a staging or testing environment, and then but when it is actually deployed to production, we call it as continuous deployment. Sometimes the transition from delivery to stage may be either automated automatically to have a programmed release, a programmed deployment, or it can be done manually too. Next slide, please. So then you have what is known as two of the pipelines. CI pipeline involves a task of building and testing and so on. And there are some specific tools that are enablers separating this. Similarly, next slide, please. The next fundamental pipeline. Next slide, please. So the CD pipeline, which actually does the delivery and the deployment of the application artifact or the packages, and then that's also enabled by a set of tools. So the next one. So then we will see what are all the steps involved in implementing the DevSecOps. So next one, please. So first of all, one of the first things that is required is an organizational preparedness, which consists of putting together a cross-functional team consisting of developers, security specialists, and IT operations, and then defining roles and responsibilities for the team as a whole and for each individual members. Next slide, please. And then some of the example roles and responsibilities are outlined for each one of the team. The development team is to design the software dependencies and what are all in other words, taking the software bill of materials, what's going to be the local code and off-shelf libraries and outsourced modules, and then the list of tests. The security team will decide on the vulnerability test and both the runtime test and static test, and then how to sign the code when it moves from one stage to the other and so on. And then the operations team will create the package and then deploy it to the actual infrastructure. Next one, please. And then what does a DevSecOp yesterday, if you had been there, you would have heard about what is known as the platform one and so on. So in other words, what exactly when you call by DevSecOp platforms? So the DevSecOp platforms consist of a bunch of different types of software. One is, of course, the primary driver software. It's a CI and CD software, which take the software lifecycle through the different stages by invoking the corresponding tools at the proper time, so-called tool chains that are involved in SDLC. The next one, please. So next one, please. So the next to the pipeline software is the actual SDLC software, like the build tools. That is the fundamental brick and mortar tools that are required for software building, the IDEs and the testing tools and so on. And then we need repositories for storing all the source code, and then as well as the compiled code on the images, that especially when it is implemented as containers. So that's a third class of components. Next one, please. Then last but not least, as I said, the various types of observability tools which are actually going to do during the runtime, like the log aggregation tools that generate the metrics, and then the tracing tools and the visualization tools that provide the dashboard and so on. Next one, please. So how do you execute them? So having assembled these 4 types of software, pipeline, SDLC, repositories, and observability tools, and we have to make sure that these components themselves are secure, because we want to securely execute the pipeline itself, and then either by certification, validation, or customized testing. And then you have to integrate all the SDSD tools with actually the pipeline tools. Next one, please. And then whatever the configuration, you have to describe it in terms of code, because that's what the advantage of having infrastructure as a code. So there you have to use the concept of providers. So provider means that is the environment in which you are going to deploy the software, either on-premise or hybrid cloud or public cloud and so on. Correspondingly, you should be able to describe the resources associated with this particular cloud or the on-premise resources. And then after integrating all these tools, you execute the pipeline tools, and then you have to also to activate the runtime tools for monitoring. So what are the next slide, please? So then you have to do the usual security for the pipeline in terms of hardening the servers, signing the code, and having access control as to who can check in and out of the repositories, and then logging all the update activities, the build activities, and so on and so forth. Next one, please. And then, of course, there are some security that is specific to the pipeline in terms of verifying the signatures, verifying that all the signatures is there before the release, and then during the runtime, to monitoring the drifts between the actual configuration and the programmed configuration, and make adjustments accordingly. Next one, please. So what are the benefits of DevSecOps? We are going to see it briefly. So next one, please. So it increases, of course, the very motive is to increase the collaboration between the various teams, and then, of course, implement a certain way of designing the system, which results in reduction of attack services by implementing zero trust, which restricts through microsegmentation the lateral movement, and also prevents attack escalation and so on. Next one, please. And then you do have another benefit is the feedback mechanism. At the various later stages, provide feedback to the earlier stages to do correction right there. So that is part of the agile development. So you reduce the time required for the taking care of the feedback and so on. And last but not the least, you are able to make security assumptions. Like you can have various risk management framework to make security assumptions for the various types of codes. Next one, please. And then last but not the least, the very motivation for developing the platform one of the earliest platforms for the DevSecOps is to check for compliance code. So you can check whether the code is in compliance with all the regulations and so on. and also associated with the various types of risk. So you can check the various critical codes, the one that generates the deployment resources, and then one that generates various types of policies like authentication, authorization, and also the basic network and session management codes. And all these you are able to get through some of the metrics that are displayed on the dashboard and also the alerts that are provided. Next one, please. I think I'm done. So this is these are some of the conceptual principles that are stated in the particular document, which is actually through the comment phase, but you are definitely required in case we have addressed nearly 110 comments that we have received so far, and it is on the way to be published. But if anyone does want to send, so they can send directly email to me, because we have closed the comment period, but we'll be happy to address any concerns that you may have prior to the publication, which we are hoping for in early or mid-February. So thank you very much.
Great, Mouli. We have a couple questions that we can try to squeeze in here.
Okay.
The first is, how do you ensure that the DevSecOp tools that you use are not compromised?
So actually, as I said, the DevSecOp, there are a variety of tools. One is the basic pipeline tools itself, and then of course various specialized tools that are used in SDLC, and then the infrastructure as code and observability code. Yeah, there are a lot of tools that, as I said, so the various ways to ensure that they themselves are not compromised is to use secure practices for coding and testing and so on. And then of course, augmented by certain certifications. And last but not the least, providing a valid software bill of materials, so that when you do the integration testing, you are taking into account all the pieces. And that's the only way we can ensure that the DevSecOps tools itself are not compromised. The usual due diligence that you apply for any other tool.
Great. So we have 1 more minute. Try to get this one in. The question is, security culture is a major challenge for most companies looking at shifting left. Is this an area NIST will be providing some guidance on, or best practice and pitfalls to avoid?
See, one of the things that DevSecOps really does is, normally we say that as per the DevSecOps process, security shifted left. So in effect, it is not really, it is shifted left, because security testing of using the SAST, DAST, and the SCA tool starts in the build phase. But apart from that, these very same security tools are used not only during the build stage, but also in the packaging stage, and but also prior to deployment as well. In other words, it is used in all the stages, those security tools. So in other words, as part of the guidance, and you know that even some of the things that we are going to be advocating in some of the other guidances that even Ron Ross talked about, that the emphasis on the security is now, it is not a separate phase by itself. It is an integral part of all the stages or phases. And that's the one that we are going to emphasize in all the guidance tools. And fortunately, the market is offering enough of tools of those various categories, like the static vulnerabilities, runtime vulnerabilities, and software composition analysis, because most of the tools now are built using a combination of outside libraries, outsourced code, and so on and so forth. So, and yeah, the answer to that.
All right. Well, thank you very much. That's all the time we have for questions.